Alright, so welcome to today's class, and in today's class we are going to be diving into chemistry, and I'm going to be showing to you how we can balance chemical equations. We can balance chemical equations, simple and easy steps rather. So I'm going to start from a very simple equation, and then we'll move to the complex ones. Alright, so this equation we see here is the equation illustrating the chemical reaction between hydrogen gas and oxygen, all right, to form water. Hydrogen and oxygen to form water. So if you can see it in this chemical equation, you can see that 1 mole of hydrogen reacting with 1 mole of oxygen to give you 1 mole of water. So a question, is this chemical equation balanced? How do I know that the chemical equation is balanced? To know that the chemical equation is balanced, the number of moles of atoms left-hand side called the reactants of that chemical equation has to be equals to the number of moles of product. What I mean is that the number of moles of the reactants, the elements involved in the reactants, must be equal to the number of moles of the elements involved in the product. So doing that, achieving that gets you a balanced chemical equation. So looking at this, you can see that 1 mole of hydrogen, okay, we have that in the left, that's the reactant, and you can see here that will give you 1 mole of water. But the interesting thing here is that if you multiply the number of moles by the atoms of hydrogen, you're going to have 2, and multiply the number of moles by the number of atoms of hydrogen, you still have 2. So hydrogen seems to be balanced, but the problem is with oxygen. Multiply the number of moles, the coefficient of O2 here is 1, and that's the moles, by 2, that gives you 2. But if you see, the number of moles of water here affects both hydrogen and oxygen. If you multiply by the number of atoms of oxygen here is 1, you can see that oxygen here is 2, and then oxygen here is 1, so it's not balanced. So to achieve this, what we have here is higher, that's the oxygen, than the product. So what we're going to do is, it's simple. What are we going to add here to make the number of moles of oxygen to be the same? Of course, you can see something here times 1 will give you 2. So that thing has to be obviously 2 moles of water. So adding 2 to water, and you would see, and you would agree with me, that the number of moles of hydrogen is no longer 2, but now 4. What will I do to make that of hydrogen the same here? I'm going to add 2 to this hydrogen. So if you can see now, this is 4. 2 times 2, that gives you 4 for hydrogen, and then this 1 times 2, that gives you 2 for oxygen, and then you can see that also gives you 2 for oxygen, and 2 times 2 gives you 4 for hydrogen. So that chemical equation is balanced. All right, this is a very simple trial and error method of balancing simple chemical equations. All right, now when we are going to be looking at a complex chemical equation, using this trial and error method could be a bit difficult. All right, it could be cumbersome. So I would love to introduce to you the simultaneous equation method of balancing chemical equations. Very simple, quick and simple. So how do you understand this? Let's look at the simultaneous equation method. Let's continue. All right. So the same thing, not using trial and error, but we want to use a defined set of equations to balance that simple chemical equation. All right. So the first thing we're going to do is that balancing a chemical equation involves changing the moles, the number of moles of each of the reactants and the product. That's what balancing chemical equation involves. So on the strength of that knowledge, we are going to assign coefficients A, B, and C to each of the reactants and the product. So doing that means that at the end of the day, finding the value of A, B, and C has obviously help us to balance the equation. So using simultaneous equations, all right, let's look at this. In this overall chemical equation, we have three elements. The first element we have here is oxygen. The second element we have here is the first element we have here is hydrogen. The second element we have here is oxygen. Of course, the element we have in the product is the same element we have in the reactants. All right. So we can't have any element in the product which is not there in the reactant. So there's an element in the reactant that gives rise to the product, the element in the product, though different substances, but the element doesn't change. So we proceed. The first element we have here is hydrogen. So you can just tag it H. You can just tag it H. All right. And the second element present in this overall chemical equation is oxygen. You can just tag it O. All right. So from there, you can see that for hydrogen, because balancing chemical equation involves that you multiply the mole by the atoms. 2 times A gives you 2A. Is there any other hydrogen here? No, because this is a mathematical expression. We say this is equals to, I've seen another hydrogen here. So this is 2 times C, which is 2C. All right, let's go to oxygen. 2 times B. So oxygen will be 2B. Can I see any other oxygen here? Yes, of course. So this is one atom. It is 1. So 1 times C, this is equals to C. Is equals to C. All right. So obviously this is equation 1 and this is equation 2. Having these two equations, we can solve this simultaneously. Now, in an attempt to solve this simultaneously, we begin by setting A to be 1. Set A to be equals to 1. When you set A to be 1, you can look for the equation that would help you make use of the value of A as 1 to find any other variable which you have present. So looking at equation 1, that's a perfect equation to start with. From equation 1, you can see that setting A as 1, this is 2 into 1 equals to 2C. So that's obviously 2 into 1, that's 2 times 1. That will give you 2 equals to 2C. So to find C, I'm going to divide both sides by 2. So you can see there that 1 is equals to C, or C is equals to 1. All right. So C is equals to 1. All right. So if you watch closely, we know that A is 1. We just found C as 1. The next thing is let's find the value of B. Let's find the value of B. So putting C equals to 1, or substituting C equals to 1 into equation 2, this becomes 2B equals to, in place of C, I put 1. So to find B, divide both sides by 2. Divide both sides by 2. Equals to 1 over 2. So you can see here that my value of A is 1, my value of C is 1, my value of B is 1 over 2. Let's continue. All right. So we arrived at the conclusion that the value of A is 1, B is half, and C is 1. But we putting this into the equation, you can see that this is like saying 1 H2 plus 1 over 2 O2, giving you 1 H2O. Now this one is invisible. It's not necessary you put this one, right? But just to let you know, it's not necessary. But the problem we have with this balanced chemical equation, yes, I know that this is correct, but the problem we have here is that moles are not represented as fractions. Number of moles are not represented as fractions. So you must make sure that these moles are not fractions. So we must do that. So to do that, all right, you can see that the coefficient, the moles here is 1. The denominator is 1. Like saying 1 over 1. This is 1 over 2. And this is 1 over 1. Okay, I can write it. 1 over 1, 1 over 1. So we're going to find the LCM of 1, 2, and 1. the LCM of the denominators of each of the moles of these elements is 2. So I'm going to multiply each of the reactants by the LCM 2. So multiplying this by 2, this is going to be 2 all over 1 H2, which is going to be 2 moles of hydrogen gas. Plus, multiplying this by 2, this is 2 times, multiplying it by 2, 2 cancels 2, so everything there is 1 over 2. Giving you, multiplying this by 2, everything here multiplied by 2, this is 2 moles of water. So the balanced chemical equation becomes so this, as you can see, when we use the trial and error method, this was what we have. And then when we use the simultaneous equation method, this is the same thing we have. This is a very simple chemical equation, one of the simplest chemical equations. I'm going to be dropping more complex chemical equations in the comment section. All right. So stay tuned because the simultaneous equation method is very helpful in balancing a complex chemical equation. Thank you. All right. So you can like, you can subscribe, and you can hit the notification bell so that you'll be notified whenever I release new videos. Don't forget, learn with master. All right. So you can share this on all your social media handles, and see you in my next class.